Alright, so today we're going to be talking about imaginary numbers. And the thing about imaginary numbers is that it may make a whole lot of sense just right off the bat, or it may make zero sense right off the bat. But when you work a few problems, it begins to click, okay? So if at first it does not make sense, just trust the lesson. And then when you get to the homework, by looking at your examples, it should begin to click. Okay? So, again, imaginary numbers is today's topic. Okay? I've been doing a terrible job spelling today, so just be prepared. Alright, so previously, when we were solving quadratic equations, if we had the square root of a negative number, alright, we can't do it. We said no.
Excuse the interruption. We need all bad numbers to report to the manual.
Alright. We said no real solutions, okay? Key word there is real. Alright? There are no real solutions, but there are some imaginary solutions. There are solutions to this. They're just imaginary. Okay? So it's important that we understand imaginary numbers so that we can fully complete those problems. We can come to a conclusion. We can have some answers. Alright? So the first thing we want to look at when we talk about imaginary numbers is the imaginary unit I. Okay? The imaginary unit I. Alright? And the I is going to let us describe this, or find an answer for this. And we write I like this, okay, yes, it looks like a J, or all you guys been giving me problems for this, but this is just a way to distinguish this I from this I. Okay, so we just write like this so that we know we're talking about math, if that makes sense. Same way that X sometimes looks a little bit different, or T. Okay, so I equals, we're going to define I as the square root of negative 1. Okay, we're going to define I as the square root of negative 1. Okay, that's what I is, the square root of negative 1. And if I is the square root of negative 1, then I squared is negative 1. Okay, I squared is negative 1. Okay, and that's because if we square I here, we also have to square this side. And when you square a root, they're inverse operations, so they undo each other. You're just left with negative 1. So we have these two facts, okay, once we define I as a square root of negative 1. Alright? Knowing this, there are two properties that we need to know. Okay, there's two properties. First property is that if you have the square root of a negative real number, okay, the square root of a negative real number, alright, you can write that as, or that's equal to, I times the square root of R. Okay, that's equal to I times the square root of R. Alright, and that will make more sense in the example I'm about to show you, or the demonstration. Okay, so if we go back to the square root of negative 5, we said that before this was not a real solution. Okay, well, we can find the solution for this. Alright, we can use this property here. Okay, negative 5, the square root of negative 5, is that the same as negative 1 times negative 5? Is negative 5 the same as negative 1 times negative 5? Yeah. Negative 1, oh, sorry. No, you're right, it's not. It's the same as negative 1 times 5, right? Okay. So just like the properties that we know about radicals, we can split those up. So that's really square root of negative 1 times the square root of 5. We can split up multiplication under a radical. Okay. Well, what did we say the square root of negative 1 is? I. We said it's I. So this is actually I times the square root of 5. Okay. Now this is a solution. Okay. This is an imaginary number. So instead of before having a negative under the radical and not having a real solution, we now have an imaginary solution. Okay. So we have a better answer. We have a better way to describe the problems that we've seen so far, the quadratic equations. Alright? The second property that we need to know is the reverse of this. Okay? So if we have I times the square root of r, if we square it, okay, if we square it, this right here is another one of the properties of radicals. This is the product property. We have I times the square root of r, so we can distribute this power here. Okay, so the 2 can go with the I, so that's I squared. Well, what is I squared? Negative 1. Okay, well, what is the square root of r squared? Hold on a second. There's announcements. Okay. So if we square a root, they're inverses of each other, so they undo each other. They cancel out. We're just left with the r. So negative 1 times r, or, in other words, negative r. Okay. So if we wanted to just work a few problems, we're going to try to beat the early release. Okay. Understand these properties. If we take the square root of negative 81, all right, we can just take this negative 1 out. Okay, we can take the square root of negative 1. Well, the square root of negative 1 is I. Okay, this is really negative 1 times 81. Well, the square root of negative 1 is I, so we can rewrite that negative outside as I times the square root of 81. Well, what is the square root of 81? 9. Okay, so this is really 9 times I. Okay, and we write the 9 first. We don't write I 9, we write 9I. We always write the coefficient first. So this is 9 times I. So all we do is, if we have a negative under the radical, we simplify that as I. Okay, now if we have the root of negative 56, our first step is to take care of this negative. So we simplify that to I times the square root of 56. Alright, is 56 a perfect square? No. So we have to factor tree. Okay, we have to break it down. Okay, 2 factors of 56 are 7 and 8. 8 breaks down to 2 and 4. And 4 breaks down to 2 and 2. Okay, since we're taking the root, we're looking for a pair. Is there a pair here? There's a pair of 2's. So we're going to pull out that 2. We're going to take out that 2. So we have 2I. Okay, 2I now. The 2 came out of the 56. So we have 2I. And what's left is what's left here. Okay, normally we've just been having one number left. So we would put the 2 here. Just give me a second. Well, now we have 2 numbers. So all we're going to do is multiply these 2 numbers together and put it under the radical. So instead of 2 and 7, it's 2 times 7, which is 14. Okay, and that is your answer. So now we have an imaginary solution. Okay, this is imaginary numbers in a nutshell.